Hello, science family. Today we're going to be looking into the candle lab. So we're going to be looking and trying to figure out kind of what exactly allows a candle to work. Now, this is one of our first labs, so we're going to focus on observations. And when we write down observations, the way you describe something and I describe something might be slightly different. So we want to make sure that we're descriptive when we write, so that we both can understand what each other is seeing. Now remember, when we do experiments, it could be for anything, pharmaceutical companies to make a new drug. It could be for a new type of clothing dye to have a new color and make sure that it's not, poisonous to people. We want to make sure that any test we do, we are good at our communication so that everyone can understand. And when we mean something specific, everybody knows what we're talking about. So the candle lab is going to help us get warmed up into that. And we'll do a little bit of a controlled experiment to start to figure out what exactly is it that allows a candle to work. Is it the wick? Is it the wax? Let's talk about it. Wick? Is it the wax? Let's talk about it. All right, so the first thing, if you look into your lab, even though you can't physically hold the candle right now because it's through video, it's asking about its appearance, odor, and feel of the unlit candle. So let's look at this official candle, all right? Can you write down its appearance? What color is it? Is it smooth? Is it have bumpy, etc.? All right, now I know you can't smell it, but I'll smell it, and it actually has no odor, so there's no smell to it whatsoever. And when you feel it, it is a little bit bumpy in that. All right, so it has ridges on it, okay? So now that you've seen that, do your best to describe that as good as you can on your lab write-up, okay? Also, write down the parts of a candle. What make a candle up that you need in order for it to work, all right? Don't forget, there's the wax, right? And the wax can be different colors, sometimes have different scents. Maybe you burn candles at your house to set off a pumpkin scent or an apple pie scent. And then in the middle, don't forget, this little part here that almost looks like string is called a wick. So make sure you write that down too in your observations on your lab. The last part then is, what state, physical state, is this candle in right now? Remember, the three states of matter are solid, liquid, and gas. So when you look at this, this is simply just a solid candle. So make sure you write that down as well and be clear. Now remember, since this is a video, feel free to pause it at any time to make sure you can write down all of your observations in your lab write-up. There's no need to feel rushed or that, but keep that in mind. You can always hit that pause button and then play when you're ready to move on. All right, our next step, part 2 in the lab, says that it wants us to take a match and heat the bottom of the candle so that eventually we can stick it to our little glass square here, all right? That'll keep it. So simple enough, we're going to take a match. As always, when we're dealing with an open flame, lab safety is a concern, right? So make sure that you don't have any loose articles of clothing that could easily catch on fire. Whenever you use fire in a lab, make sure that your hair is tied back. You don't want to start that on fire, all right? But so we have the match. What I'm going to do here is I'm going to light and melt the bottom of the candle a little bit. And then I'm going to stick it on to this glass square, all right? What that is going to do is, now that that wax melted a little bit and then stuck on there and hardened, now I have my candle stuck to the glass square so that it's easier to use and move around. Part of the lab now says simply to light the candle and let it burn a few minutes. When you do that, you're going to watch it and list any changes that occur in the candle. So let's light this up. So we've lit our candle and we've been letting it burn for several minutes. Now I'm going to bring that candle a little bit closer so that you can see. But the hard part, because it's glowing in that, is you might not be able to completely see, but if you've ever used a candle before, you know. So there's a flame, there's still the solid wax, right? But inside is the bowl of the candle, and there's a little puddle of melted wax in there. So when you start thinking about what phase or phases are present when there's a lit candle, is there solid? Yes, there's still solid wax. Is there liquid? Yes. Underneath the flame in the bowl of the candle is the liquid wax. And then is there gas? Well, let's think about that. If something burns, is that giving off some type of gas? Whenever we burn something, the answer is yes. In fact, this is giving off what's called carbon dioxide. So actually all three phases are present. Now, one of the questions in your lab besides the phases is what type of energy was used to light that candle? So when we lit our match, what type of energy was that in order to start the candle? Was it heat or thermal energy? Was it light energy? There was quite a bit actually of energy going on, but the main one would be heat or thermal energy that helped light that candle. And the last question is, do you think the burning candle reaction absorbed or gave off heat? If you have a lit candle and you put your hand by it, do you think you feel the heat coming off of the candle, or do you feel like we're putting heat into the candle? So think about that and write your answer on your lab. Now that you've written down your observations for part 2, and remember, the goal of this lab is for our observations to be clear. So make sure you're writing legibly and with details that everyone would understand. It would mean the same to them. So I'm going to take another square here, put that down. I'm going to melt the bottom of a birthday candle really quick so that we can get that candle standing up. So let's just get that wax a little light. There we go. Stand up that candle. Now that we have our candle standing up, let's light that candle really quick. Get it burning. And we'll blow the flame out and then bring another flame close by to see if it needs the flame to actually touch the wick in order to work. The flame has been lit on the birthday candle. I've got my one match ready over here. I'm going to blow out the candle and see if I can relight it quick without touching the wick. Did you see that? It's like the birthday candle relights quickly without the flame actually having to touch the wick. Go ahead and write your observations down and your thoughts. Remember to read the lab to see what it's asking you to do. So we are in part 4, and what we're going to do is transfer this liquid melted wax onto this micro spatula. We're then going to see what happens with the states of matter if anything changes. So we know that the wax is liquid in there right now, but when it transfers to the micro spatula, let's see if anything else happens. So I'm going to blow this out. I'm going to transfer some of that wax to the micro spatula. You saw some of the wax pour off already. And now, some of it's liquid, but take a look at this micro spatula. It started off as liquid wax, but now the wax is slowly hardening. So by not being near the fire, the wax looks like it turned back into a solid. If you need to pause the video, go ahead and write down those observations, but there was a phase change. It went from liquid wax back to solid simply by being put on a cooler piece of glass. Now the lab in part 4 asks us to try to light this wax. If you think about this, this is going to be a controlled experiment. Why? Because the candle is made of wax and a wick. What we're doing is taking away the wick now, changing one thing. And by changing one thing, now you've created a variable. And we can see if the candle needs to work with a wick or if we can just burn the wax. So let's try that out. I'm going to get myself a match and I'm going to attempt to light this wax and see if it catches on fire, just like a candle would. So here we go. Let's see. Well, the match is burning very well, but unfortunately the wax is not catching. In fact, it is simply just turning back to liquid. You can see a little bit of the black soot from the burning match, but nothing too crazy. So the wax looks like it won't burn, it just simply melts again. So that's another observation. Make sure if you need to, you can pause this video, write down the observation in the proper part during part 4. For part 5 of the candle lab, if you can see, I took a small piece of a toothpick and I shoved it down into the candle. What we're going to compare is the different wicks. We know that this wick is some type of string-like substance, all right? What about a wooden toothpick? Would that work just as well? So we're gonna test that theory out. And again, this is a controlled experiment because we're still keeping the candle wax, but we're now using a different type of material for the wick. So let's see if that actually makes a difference. So we're gonna fire up a match. Again, as always with fire, be extra safe. Let's slowly light this toothpick. And let's compare the burning toothpick wick to the traditional candle wick. And what did you notice? Looks like our toothpick wick didn't get much action. In fact, it's a little glowing ember, but unfortunately, it doesn't have that continuous flame. So for some reason, a candle likes using the traditional wick over a wooden wick. But what you did was a controlled experiment. You made everything the same about this candle, but instead of using the traditional wick, you used that toothpick wick. And as you can see, the toothpick didn't burn very well. Okay, pause and write down your observations if you need to. Since we're testing out wicks, we tried the wooden toothpick. Now we have a nice thin piece of string here. And what I'm gonna do is I'm gonna put that string on this glass square. And we're gonna attempt to light that string and see how it compares to the wick that burns in a candle. So let me see if I can get this started. Wow, did you see that? It burned really fast. So that wick string there burns a lot quicker than a wick does in a candle. I wonder if there's a reason for that. In fact, if you think about the word wick, right? Anything that is wicking means like absorbing. So I wonder if there's something to do with this traditional wick inside the candle that absorbed something so that it slows down the burning process. Something interesting to think about. But as far as part 6 is concerned with the string, go ahead and pause this and write down your observations of what you thought. Remember to write clearly and concisely so everyone can understand what you're talking about. Part 7, we're gonna bring back our birthday candle and we're gonna light it up. But we took a piece of foil here, and I don't know if you can see it, but we made almost like a mouth, a little opening, a slit. What we're going to do is try to separate the flame of the burning wick from the wax so that we can see, does the flame in the wick have to be near the wax in order for the candle to burn? So we're just simply going to create that new variable, that new change, keep everything else the same, the burning candle is still the same, but we're gonna cut off the flame from touching the wax and see if that has an effect on it at all. So let's light up our birthday candle. So I'm gonna cut that off and let's see. Once that wax is blocked, the wick flame gets smaller. So definitely, for some reason, it looks like the wax helps the flame and the candle burn. And it went out. So it looks like you need the wax and the wick together in order to make the candle work. Is that an observation maybe you need to write down? We'll take a look in part 7 and make sure you answer properly. And don't forget, you always want to make sure you're answering your observations clearly and concisely so everyone can understand. For our final part 8 of the candle lab, we're looking at observations. I'm going to put this candle back on, so I'm going to light it up. And then we are going to get a beaker. Now the beaker is going to go over the candle, and we're gonna see what happened. Notice that the candle will not hit the top of the beaker. We're just going to put it over the top. So I'm gonna hold that beaker over the top. We'll see if there's anything we can observe. So that flame is flickering. It's not completely going out. But if you notice, the beaker is starting to get foggy. So there must be some kind of gas that's being given off by the candle, and then that gas is hitting the cold beaker And it looks like it's almost turning back to a liquid because that's what a fog is on a glass. It's like condensation. So let's see. If I look inside here, let me feel. It's wet. It actually is water. So interestingly enough, when a candle is burning, that flame is giving off gas that is water, H2O. And when you hold it upside down and that gaseous water, that water vapor hits a cold beaker, it turns back to liquid. So interesting, the water that was vapor condensed back on the beaker, all right? So that was part 8 of the experiment. Write down your observations, make sure you read what it's asking. When you write observations, make sure you're clear and concise so that they mean the same thing for everyone. Now that we've completed all 8 parts of the lab, the questions you have to think about are this. First of all, what is it that you really need in order to have a candle that's successful? A successful candle stays lit and continues to burn slowly. So what is that? Go ahead and write your answer down on what you think a candle needs in order for it to burn slowly and consistently. The last question's a good one, is what else could you make the parts of a candle out of besides what you saw today? So instead of that wick being almost like a string-like substance, is there something else you could do? Remember, you want it to burn slowly. And then also for the wax, is there anything else you could use besides the wax? If you're completely clueless on this and you think, wow, I don't even know, don't forget you have the internet. You can look and see maybe people have made candles throughout the years in other ways besides just using wax. But that might help you answer your question. So this concludes our candle lab. Thanks for following along. Make sure, as always, for lab write-ups, you proofread what you wrote. Spelling is important. Make sure you're writing complete sentences and that it's understandable. That's always important. Also, when you reread your answers, sometimes you might find that you don't completely make sense. It did in your head, but when you read it out loud, to a person reading it from the outside, it might not make sense. And then we were focusing on observations and writing clearly and concisely, but in the end, we actually did what's called a controlled experiment. We separated out different parts. We took out the wax and just looked at the string or the wick. By doing that, you contained and controlled one thing at a time. And by changing only one thing at a time, you only have one variable, and that allows for an easier reasoning system so you can figure out what affects what. So we'll talk more about that in class, but keep that in mind. When we do experiments, we only want to change one thing at a time. All right, science family, thanks for listening, and hopefully you got a little practice with observations and a good intro to some of our science things today. Take care.